For this experiment, we will be investigating the equilibrium of a meter rule with a chain attached. So, we're first told to attach the boss to the stand at a height of approximately 60 centimeters above the bench. This is our boss, our stand, our bench. We're then told to assemble the apparatus as shown in the diagram and make sure that the nail head is held securely in the boss. We're also told to attach one end of the chain of paper clips to the string loop and allow the other end to just rest on the bench. So right here is our string loop, this is our meter rule, and this is our chain of paper clips, and it just kind of rests on the bench. It then says to attach the piece of adhesive putty to the meter rule approximately 40 centimeters from the nail. So our X value here should be approximately 40 centimeters. We're then told to measure and record the distance X between the nail and the center of the piece. So really we would aim to get our ruler as center as possible on both and then measure the distance. So hopefully, since they've asked for it to be 40 centimeters apart, we have an X value of 40.0 centimeters. However, there is room for flexibility, so anything ranging from 38.0 to 42.0 centimeters is acceptable. What isn't acceptable is for our answer to not be to the nearest millimeter. So 40 centimeters alone would not get the mark. You have to write 40.0 centimeters because that is how accurate our ruler is. So you could get 38.2, 38.3, as long as it's to the nearest millimeter and it lies within this range. It then says to measure and record the angle theta between the meter rule and the plumb line as shown in the figure. Now, you would usually take your protractor to measure this angle. The acceptable range would be from 60 degrees to 100 degrees. I'm just going to go with 80 degrees, and your answer should be to the nearest degree and within this range to gain the full mark. We're then told to vary X and then measure theta for each X value. We're told to generate 6 sets of values and to not use a value of X less than 15 centimeters. And then to record our results in a table and to include cos theta values in our table. So we need one column for the X measurements, one column for the theta, and then an additional column because they've asked us to generate a cos theta column. Now, this is actually worth 10 marks, and it's worth taking a look at what these marks are actually for. So you gain 5 marks to start off if you have 6 or more readings that follow the correct trend. And by that we mean as the X value increases, the theta value decreases. And this is without help from the supervisor. 5 sets would score 4 marks. Okay, then our 6th mark is for our X values to be within the range 20. So we have to have an X value that's less than or equal to 20, but obviously no less than 15, and then an X value that is greater than or equal to 45 centimeters. So what I did is I just went from 15 and I did 5 up each time, and it just happened to be that my last value was actually 45. So try to do as big a range as possible. You have to ensure that you don't go too far from your lower limit, but at the same time you also have to consider the length of the rod. So yeah, that is for your 6th mark. Then for your 7th mark, your column headings are what gain you this mark. You have to have the quantities and a separating line for your quantity and your unit. So a lot of people on this paper actually ended up doing something like this. This does not count there has to be a line that separates the unit from the quantity. And obviously you have to make sure you actually put down your units. Cos theta does not have a unit because it just generates values. So that wouldn't have a unit. Another thing is your 8th mark is for consistency. Oh, 7th mark, I think, yeah, is for consistency in rounding your values of theta to the nearest degree. Because remember, your protractor can only measure to the nearest degree. Your values cannot be more precise than the instrument you're using. Now, the 9th mark is for the significant figures of cos theta, okay, these lot. So basically, your cos theta values should either have the same number of significant figures as your theta value or one more than that. So in this case, for example, we have 2 significant figures, so I just went with 2 significant figures. In this case, we only have 1 significant figure, but it just felt right to do my cos theta to 2 significant figures. Same with 100 as well as 90, and yeah. So they accept equal significant figures as theta values or +1 from that. Okay? And then last but not least, calculations of cos theta need to be correct. So you can't have used sine theta, for example. Just ensure that you're taking your time with your calculations and you're actually getting them right. Then we're asked to draw plot the graph of cos theta on the y-axis and x on the x-axis. Then draw a line of best fit and determine the gradient and y-intercept of this line. Just one thing I'd like to know is these values right here are not accurate whatsoever. These are made up values, they just follow the correct trend, and it's just used for educational purposes. You might not, and most likely won't, receive values like this in the actual experiment. So, to plotting. Okay, let's see. This is the graph that I had plotted, and this graph is worth 3 marks. So the things they take note of is, first of all, use of sensible scales. I'm just gonna write down here on the side. Scales must be sensible. Scales you should aim for is like going up in units of 1, 2, 5. So going up 5 units, 2 units, 1 units. Fractions aren't credited. 3 to 10 ratios also aren't credited. So you want an even distribution. You want to go up by 2 each and every time, okay? Also, your scales need to be so that when you plot your graph, it fills in at least half of your graph, basically, or your grid, sorry. Otherwise, it's going to be too small of a graph and you're not going to gain the mark. Your scales must be labeled with the quantities, so x and cos theta, as well as, of course, the units. Also, a note to make is that a scale markings should not be more than 3 large squares apart. Okay, this would be 3 large squares. This would be 3 large squares. Okay? And yeah, so that's in terms of our axes. Okay? Then in terms of plotting our points, all observations made should be plotted. Just because you feel like the plot points don't match up with what the graph you think might look like, doesn't mean you shouldn't note it down. If you feel that one of the points just doesn't go with the rest, circle it like so, and they will realize that it's an anomaly, and that's completely fine. The diameter of the plotted points need to be less than half a small square. So essentially, this is a small square. This is half, sorry. Your circles should not, so these circles right here, should not be any bigger than that. Or else you won't get credit because they can't judge where you've placed your dot. This should be the case for both the x and y directions. And they have to be as accurate as possible. So at least 5 points need to be plotted from your table. Obviously, like we said, you need to plot them all, but if you've only made 5 recordings, then they should all be plotted. The trend should be correct, so it should go in an upwards direction. I mean, it makes sense too. The reason being, well, if we push this putty to the right, then it's going to weigh more on this end, and so this will go lower down and this angle would decrease. Okay, so it gives an indicator if you're doing this right or not. And last but not least, your scatter of plotted points must be no more than plus or minus 0.05 from a straight line on the cosine theta axis, which essentially means your line has to be as straight as possible and it shouldn't deviate too much from, the points shouldn't deviate too much from your straight line. So basically, your line of best fit doesn't actually have to go through all the points. However, they shouldn't lie too far out from the line unless they're an anomaly that you have circled. Okay, so let's just go ahead with drawing our line of best fit. I'm just going to pull out a ruler. You should be using a ruler because you don't want to mess this one up. And it's really difficult to draw a straight line otherwise. Okie dokie. Okay, so I'm just going to draw a line right through. Hopefully this works out. And it's just gone through these 3 points. Okay. Now, the one I do feel is a bit far out from the others is probably this one. So I'm just going to circle it to show that it's an anomaly. And, well, okay, so this was meant to go through the 3 points. So I'm just going to redo that real quick. It is a bit difficult, so you have to be careful to get it through all 3, but hopefully we can manage. Okay. Oh, have I accidentally erased it? Okay, there you go. Okay, let's just pretend that actually went through all 3. So it did for the most part, and now we only have 2 lying outside the line. This was worth 1 mark. Wow. Okay, so this is worth 1 mark, but in order to gain this mark, you actually have to have done a couple of things. There should be at least 5 points on this that you considered non-anomalies. There has to be an even distribution of the points on either line, and that's why I tried to make it go through these 3, so that these 2 would lie on opposite sides of the lines. I have circled an anomaly because, well, we wouldn't have an even number of points on either side of the line, plus this one does actually lie a bit further out than the rest. So 1 anomalous point is allowed. The line cannot be kinked like so, or thick, or it has to be straight and thin, and no thicker than half a square to gain that mark, okay? So remember, your graph should have a straight line trend. A lot of people do fail to actually circle their anomalous point, and so they don't end up getting the mark because it's clear that this anomalous point has been ignored. They haven't circled it or highlight or pointed towards it and wrote anomaly, so they wouldn't actually gain credit for this, according to the examiner's report, okay? So next, what do we have to do? We have to determine the gradient and the y-intercept, okay? For the gradient, let's see what we can do. So we can use the rise-run method, or the change in y over the change in x, to find the gradient. And I like to choose points that are easy to use. So I think this one right here and this one, they have to be on the line, of course. Now I'm just going to pretend that these points are on the line, and they are meant to be, but it's difficult to do this on a device. So I'm just going to note that it's on 30 and 0. 30 and 0. As well as, what's it called? 45 and 0.21. 1. So you'd want to highlight that you're using a right angle triangle. And I'm not sure this is half, to be honest. So as a matter of fact, I might not use this point actually. I might use a point higher up so that we ensure that the triangle is a lot bigger and takes up at least half the line. So I can go with this one, for example. Right here. And then our rise, or our delta y, and then this is our run, or our delta x. So we said this is 30, 0. Up here, this is 50. 50 and, let's see, 50 and 0.34. Yep. Just going to erase this one. And then we're going to use these to determine the gradient. So the gradient is just y1 minus, or y2 minus y1 over x2 minus x1, which is equivalent to 0.34 minus 0 over 50 minus 30, which is again equivalent to 0.34 divided 20, which would give us a value of 0.017. Okay, so now that we have y equals 0.017 x plus c, by putting it in the form y equals mx plus c, what we can do is substitute our values. So I'm going to go with this because it involves a 0 and it's going to make life a lot easier. So 0 equals 0.017 times 30 plus c. Okay, 0.017 times 30 is equal to 0.51. So 0 equals 0.51 plus c. C equals negative 0.51. Yeah, and that's all we need to gain the 2 marks. However, there are some things that we need to note down. First of all, to the triangle, like we said, has to be at least half of this line. Half of this line is around about up until here-ish, I guess. Any triangles used that are smaller than that, if the hypotenuse, which is this angle opposing the right angle, is any smaller than half the line, then you won't gain credit for that. Also, you have to make sure that you're doing it the right way around. It's change over y, a change in y over change in x, not the other way around. The sign of the gradient must match the graph shown. So I have a line going up, so I should have a positive gradient. If my line was going down, then I would have a negative gradient. So I do have a positive value for my gradient, so it does align. When you're reading off these values and this value, you have to make sure that they are accurate to half a small square in both directions, okay? And then in terms of the y-intercept, the only way we could determine this would be using the y equals mx plus c method. Because one, not only does our graph not pass the y-axis, so we couldn't read off, like if the line were to go through the y-axis here, we can't read off. Two, even if it did pass through the y-axis, we still couldn't read off because our scale does not start at 0. So whenever our graph passes or the line passes through the y-axis, it wouldn't pass it at x equals 0. It only simply passes it because there's no more room left on the grid. So this is a common mistake that many people make, and that is they read off the y-intercept here, not realizing that their graph did not start at x equals 0 on the x-axis. Okay, so now they've suggested that quantities theta and x are related by the following equation, where a and b are constants. Use the answers we just calculated to determine these values. So previously we found the gradient to be 0.017, and in this case a is our gradient, so 0.017 here, and then our y-intercept was, wait, let me check. Yeah, I don't know why it says that. It was negative 0.51, and so is b. our y-intercept, because remember y equals mx plus c, negative 0.51. It says to give the appropriate units. Do not forget your units. Our y-intercept, so our y-axis was our cos theta. So this b won't have units. Our x-axis was our x in centimeters. And to find our gradient, our m, it was equal to the change in y over the change in x. So no units over centimeters. So basically, our units, so really this can be written as centimeters to the negative 1, which just means 1 over centimeters, because there's no units, we're just timesing by 1. So really, our A units is going to be centimeters to the power negative 1. That is it.